All right, so here we go. We're in 7.5, which is solving equations with fractions, basically. It's how do you solve fraction equations. So this chapter 7 that we're in, that we're halfway through, this one doesn't shine up very brightly, does it? Anyway, this chapter 7 is all about fractions. And so now specifically, we're solving equations with fractions. What we did, remember 7.4, the last section, was adding fractions. Remember we got common denominators, gave them what they're missing, top and bottom. Now, what's different now is we have an equal sign. We're solving an equation. We have a left side and a right side. All right, so how do we do it? How do we solve equations when there's fractions in there? Get rid of them. Yeah, absolutely. That's always my strategy when there's fractions. Let's just get them out of there. So what will get rid of those fractions? Common denominator, huh? The common denominator is the only denominator, 4 in this case, right? And so what do we do with it? We multiply 4, 4, 4. Is that making sense? Now, I want to help you understand. If there was another problem over here, I don't want to spend too much time on this. But I do want to give you the big idea. What if it was like that? Let me do two problems at once. Because I want to give you the big sweeping idea, because I know it can be confusing. See, this was 7.4. This is the last section we did that was on the test, right? We were just adding things. There wasn't an equation. There wasn't an equal sign. Well, then how do you do that? What does that mean? What that means is, what you want to think is in fractions, there's two ways to keep the balance. We're always keeping the balance. There's two ways you can do that. You can either do it by doing the same thing to the left of an equal sign that you do to the right of an equal sign, left and right, or top and bottom. So there's two ways to keep the balance. Do the same to the left and the right, or do the same to the top and the bottom. And I don't want that to be confusing for you, why we do it sometimes, what we do it. How do you know which one you're supposed to do when? When you have an equal sign. That's the only time you have a left and a right. So that's when you do left and right instead of top and bottom. So let me show you what I mean. So if I was doing the one on the right over here, which is what we did, last week, last section of that material, there's no equal sign here. So you might think, well, yeah, just do the same thing. This is 7.4. Just do the same thing. Just multiply by 4, multiply by 4, multiply. No, completely illegal to do that. Math cops will come for you. That's illegal. That's not true. That's what we mean by illegal. It's just fairy tale stuff. That's not true. Why? Why is it not true? You can't just be multiplying by 4. Let me make a simple example to show you. Let me make simple. What if I was adding a half and a third? Let's just keep it really simple. Let's talk about pi. I ate half the pie. Later I ate a third of the pie, right? Real life pie here. Yeah, I'm going to do a real life pie here. So if I can. Yeah, it's the best I can do. All right. So I ate half the pie. What's half? There's 6 pieces there, right? What's half the pie? 3 pieces. 3 pieces. Tomorrow's Valentine's Day. For my wife, it's cheesecake. That is the desire. I just texted her and said, so if someone was to bring you cheesecake, what would it be? Would it be the double cream lemon or anyway? So those are her favorites. She loves cheesecake. All right. So half a pie, 3 out of 6, or 1/3 of a pie. How many pieces is 1/3 of a pie? 2 pieces, right? 2 6, right? So there is a half a pie and a third of a pie, which we know is 5/6 of a pie. You know that. Now watch how crazy it would be to do like what I'm saying you can't do. If you look and go, 2 and 3, I know, common denominator 6. I'll just do that. I'll just multiply by 6 because that's a common denominator. That'd be wacko. Watch. What would happen? 2 would go into 6. How many times? 3. Denominator's gone. It's just 3 now. And 3 goes into 6. 2 times. Denominator's gone, right? Crossed out. So it's just 2, which equals what? 5. You eat a half a pie and a third of a pie, you got 5 pies. 5 pies. That's not real.
It's America.
It's America. Yes, it's America. No, it's not. It's illogical and untrue. Why? Why did that go wrong like that? Because you can't be just like multiplying by a number when you don't have an equal sign. That's what we'll do over here. It'll be fine over here because we have an equal sign. You see the difference? You can, when you have an equal sign, like on the left now. On the left, I have an equal sign. That means the left and the right are equal, aren't they? I can multiply them both by 1,000,000 if I want to. It's fine. If they were equal before, you treat them the same. They still got to be equal afterwards, right? But I have no such thing on the right side. There's no equal sign over there. So I can't be like multiplying by 4 or 2 or 6 or anything. You can't be doing that. That's not okay. You can't do that. You just make up fairy tale stuff. So then, well, then what do? Instead of left, right, we do top, bottom. Well, yeah, in fact, let me go back to the half and the third with the pi. We already know the answer is 5, 6. What would I do instead? I would do the give them what they're missing. That was the last section. That's why we did top and bottom. You see the difference? When you don't have an equal sign, you can't do just the top. That's just not true. But you do top and bottom. What would you do top and bottom? 3 here, because that would make it 6, and 2 here, huh? That's okay to do, because I'm not changing the fraction, am I? A half will become what? It'll become 3/6, and you know a half is the same as 3/6. I haven't changed anything. That's okay. And over here, this is 2/6, and there it is, the real answer, 5/6. So do you guys see the difference? If you do not have an equal sign, that was the last section, you've got to do top and bottom. You've got to do the same thing to the top and do the bottom so that you don't change anything. You keep it real, right? But over here, with an equal sign, it's actually easier. You don't have to worry about top and bottom. Why? Because we have an equal sign. I'm not going to be, today in this section, I'm not going to be thinking about top and bottom, give them what they're missing. No, this will be easier. You like this better. I'm just going to do left, right, because I have an equal sign in all these problems. So do you see that difference then? There's 2 ways we deal with fractions. We keep the balance, either top, bottom, or left, right. How do you know which one? If you have an equal sign, it's left, right. Because you have a left and a right that are equal. You can do anything you want, as long as you do to both of them, right? Whereas if you don't have an equal sign, you got to do top and bottom to keep it real, keep it true. All right, so that's the big picture. So let's forget about that and come over here. So this is right. So back to the real problem now. So when we multiply through by 4, that is true and right because they're equal, huh? The left side equals the right side. If 2 things are equal and you treat them the same, they're going to be equal afterwards. I can multiply by 1,000,000 if I wanted to on both sides. It's going to be equal afterwards. So I'm just going to do 4. These cancel. And so what does that leave me? X plus 12 and 4 times 7, 28. We good there? And last step to get X alone. And much easier about it. See, we wiped out all the fractions. So much easier, huh? When those fractions are gone. Now it's just child's play, huh? Subtract 12. X is, 16? Done. Easier. When you have an equal sign, you don't have to mess with denominators. You wipe them out on the first step. Notice I don't do top, bottom. I do left, right when there's an equal sign. Questions? Get that big idea? That's something you ever had down clear before with fractions? Number 2 here, 4 minus 12 over x. 4 minus 12 over x equals 8. All right, let's try that one. So we have an equal sign. So we're thinking left, right, not top, bottom. So just identify the common denominator. What is the common denominator? What's the only denominator? X. So just go x, 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 top, 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 x, 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 right? Just multiply top, 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 x, x, x. X, x, x. And these cancel in the middle, don't they? Does that make sense? It'll multiply with the 4 and the 8, but it cancels in the middle. That's why we're doing it, because we want to get rid of fractions, huh? So it cancels out in the middle. So you see, I'm doing the same thing on the left that I am to it. I'm not even thinking top, bottom, because I have an equal sign. All my thinking is left, right, tops only, right? And that's legal to do, because the left side equals the right side. So what do we have then? We have 4x minus 12 is 8x. We good there? No more fraction signs. It's really nice. We get rid of the fractions on the first step. Now what do we do to solve for x? What do you do when, here's the wall, x x is saying I want to be alone. We have x on opposite sides. What do you always do to solve for x when you add it on both sides? Yeah, just get rid of one of them, huh? It doesn't really matter which one. I'll probably just get rid of this one. But you could do minus 8x also. That would work. And we get minus 12 is 4x. Last step to get x alone? Divide. Divide's always last, yeah. So then we get x is minus 3. On that one. Is that good? So see how we get rid of the fractions on the first step? We just wipe them out of there on that first step. Questions I can answer?
Mr. Aaron,
Yeah.
we cannot get the x all the way multiplying to a, get it out of the left side, and then just get the product of 4 minus 12, or keep going? No.
What do you want to do, Memo?
You see, like it's like when you have the equation that has just letters, and then you like the x is divided, and you pass it multiplying to the other side.
Oh, I hear you. Yeah, the problem is, if I just had, I see what you're saying. Yeah, if I just had this and not the other 4, then yeah, I would totally just multiply the x, and it would just be gone, and it would just be like that, just 8x. Yeah, but the problem is I have this other piece too.
So the minus is gluing the...
Yeah, well, basically, you just have to do the same thing to all 3 pieces. So in other words, I can't just take this guy and put him up there and just be dealing with this guy and this guy. He's involved too. So when there's 3 items or more, you have to, whatever you do it to all of them. So you have to do the x on all 3 on that. Number 3 is going to actually be a little bit easier. So like we were just saying, here we don't have 3 fractions, right? We just have 1 fraction on the left, a over 7. 1 big fraction on the right, a minus 3 over 4. So you can just cross multiply. It's the same thing. So in other words, you can just go diagonal, diagonal. In other words, 4 times a is 7 times a minus 3. Am I making any sense there? So if you just have 1 fraction on each side, you don't have to do the big old common denominator thing. I want you to see, though, that it's the same as doing it. Let me show you. What if I didn't do this new trick thing, and I just said, no, I'm just going to do it the same way. I want to show you that it's exactly the same result. What would be the same way? What would be, look at 4 and 7, what's the common denominator? 28, right? 4 times 7, 20. And what would you do with the 28? Top, right? We're doing left and right, okay? And then think with me, what would then happen? 7 would go into 28 how many times? 4. See what you'd have? 4a. See what I had? 4a. Same thing. What would happen on the right side? 4 would go into 28 7 times, and we'd have 7 multiplied by a minus 3. Same thing. So you see, it's just a shortcut way when you only have 1 fraction on each side. It's the same result as doing the common denominator. It's just quicker. But it's only doable, only allowable, when you only have 1 fraction on each side. Right? You tracking with me? If I had something else here, if I had, like the last one, a plus 2 or something, then I'd have to do it the longhand way and multiply through by 28, 28, 28, all 3, and cancel everything and all that. Am I making sense? So if you just have 1 fraction on each side, you can save some work and shortcut. Let me write that. So when only 1 fraction on each side, you can just cross multiply. Diagonal, cross multiply, diagonal, That's what I did. Diagonal, diagonal. If you just have 1 fraction, there's only 1 fraction on each side, you can just cross multiply. It saves you some work. You don't have to think about common numbers. But if you want to just do common denominator all the time, that'll work. It's the same result as we saw. So all right, let's take it from there. So now what'll happen? Well, this distributes. 4a is 7a minus 21. Good to there so far. Here's the wall. Remember, I think it might help if you put a wall in for the equal sign. Just helps you helps you look at it so you can see right side, left side, you know. Those sides are equal, they're balanced. So A wants to be alone. What do you do when you have A on both sides?
Cancel out one.
Yeah, cancel out one of them, huh? Get rid of one of them. Now, I think it'd be easiest to just get rid of the 7A, even though he's the bigger, because that'll just put the A on this side. Let me write that again. That'll just put the minus 3A, and the other side will be minus 21. See what happened there? Can you read that? Is that kind of scribbly? Here, let me rewrite this problem. It's getting messy. A over 7, A minus 3 over 4, A over 7, A minus 3 over 4. So again, from the beginning, I just went diagonal, diagonal, and got 4A is 7, A minus 3. Then I distributed and got that. And then I said, okay, we have A on both sides, got to get rid of one of them, and I subtracted the 7A. And I got minus 3A is minus 21. Last step. Divide, and you always divide by exactly, yeah, exactly what's next to A, the minus 3. Same sign, same everything, huh? And so what do we get then? A is positive 7. Two negatives make positive. Good on that? So if you just have one fraction each side, just cross multiply. Diagonal, diagonal. No questions? Yeah, now so that's our next one. So I want to solve for A there. So is that just one fraction on each side? Pretty much. What do you do with that minus 1 to make it look like, on the right side, to make it look like a fraction? Just put it over 1. Go diagonal, diagonal. Same thing. Yeah. So if you just have one fraction each side, or a whole number on one side, just make it look like a fraction. Go diagonal, diagonal. Cross multiply. We get there like that. Not good. Diagonal, diagonal. Not making sense what we did? Here's the wall. And now you just distribute. Everybody see what I'm doing there? I'm just putting the... And if you haven't switched left to right, that's fine. It doesn't matter which one's on the left, which one's on the right. Doesn't matter at all. Just diagonal, put it on one side, diagonal, put it on the other side. And then let's take it from there. So boom, boom. And so 13 times 1 is 13. Here we get minus 5A plus 3. We good? All right, so A is saying it wants to be alone. That's what the letters are always saying. So how do we get A alone? Subtract that 3. What is that, 10? And then last step, divide by minus 5. Boom. A is negative 2, right? We good there? Questions on that one? All right, so just cross multiply when you have just one fraction on each side. So is this just two fractions, one on each side? No, no. So I can't just do the shortcut cross multiply. I have to do it the long way. I got to multiply. Now, really, probably you're seeing, huh? What do we, before we do anything, we need to deal with that, huh? It needs to be factored, huh? Yeah. So you know how to factor that. Let's do that. So 1 over x plus 6. And what do you do with, oops, I kind of erased it, huh? What do you do with x squared minus 36? How does that factor? Yeah, plus 6 minus 6. Good to there. Okay, now Now, we're going to do, now it's time for common denominator, huh? We can't just do the shortcut because we don't just have two fractions, one on each side. We have three, or two fractions is a whole number, whatever. We have three things. So we have to do the common denominator. I'm going to do top, top, top. I'm not going to do bottom, right? I'm not thinking top, bottom. All of my thinking is left, right, because I have an equal sign. So what am I going to put in the top? Common denominator. What is the common denominator? It's this, basically. Because you just need one of every type. So you just need one x plus 6 and one x minus 6. That's everything you see in denominators, huh? So what do we do with it? Top, top, top. So x plus 6, x minus 6 there. X plus 6, x minus 6 there. X plus 6, x minus 6 there. Does that make sense? Top, top, top. Because we got to do equal treatment, don't we? This is an equation. The left side equals the right side. So whatever we do to the terms on the left, we have to do to the terms on the right, keeping the balance, the equals, the left and the right. Okay, now, can you cross cancel, and multiply whatever's left over? So cancel stuff out, multiply what's left over. So the x plus 6 will cancel the x plus 6, right? Is that making sense? What's left there? 1 and x minus 6. So far, so good. And then in the middle, this, and the top and the bottom will completely cancel, just 12.
You can't do the x minus 6 on the one part. So it'd be like 12x plus 6.
What's up? What are you talking? You talking about this middle fraction?
Yeah, I canceled out the denominator of on the 12 and then the top part of by the 1. Do you see what I'm saying? So I got 12.
Maybe I can come by and check in a
Okay.
minute with you. So that's the correct way to do it. On the right side, these guys are not going to cancel. They're just going to multiply because there's nothing to cancel. Is that making sense, what's happening? So these x plus 6 is canceled over here. Just 1 and x minus 6. Here, the whole top and bottom cancel, just 12. And then here, just that. And now we just got to multiply that stuff out. There's no more fractions. We got rid of all the fractions, didn't we?
So you're doing top and bottom instead of diagonal.
Yeah, that's all the same thing. Right? Yeah. So think about fractions for a minute. 2/3, 9/10. You can go diagonal, or you can go top and bottom. You know that already, right? Think about 2/6. What do you do with 2/6? You make it 1/3. What'd you just do? Straight down. So, right? So we've always known that, right? So you can always, so yes is my answer. You can go straight up and down or diagonal. So it's always been that way. All right, so let's keep going on this thing. So now, this is just 1. It's not going to do anything, huh? And over here, the 1 is irrelevant, but we got to FOIL this out. What do you think x plus 6 times x minus 6 is going to become?
X squared minus 36.
Yeah, that's what it came from. Remember? X squared minus 30. Can I just jump to that? I mean, if you want to write it out, it'll be x squared minus 6x plus 6x minus 36. Then these guys will cancel, and it'll be x squared minus 36. Because that's the source from which it originally came. Right? Up there in the middle denominator. Are we good so far? This is a long problem. We still have some more work to do.
Yes. Very nice.
So are we good to here? Everybody see what happens? So I multiply through by the common denominator. Cancel. Multiply what was left over. That's what you always do. You multiply common denominator, cancel, and multiply the leftovers. Down here. Now, minus 6 plus 12. What is minus 6 plus 12? Plus 6. The other side just stays the same. Good to there so far? Minus 6 plus 12 made plus 6 there. Kind of scribbled it. Right? I just combined those numbers. 12 minus 6 is 6. Right? These guys. Okay, now, what in the world should we do now? We got rid of the fractions. There's no more fractions. What are we supposed to do?
We factor it again?
We're gonna, yeah. But first, remember in the last, didn't we do this? We had a section, yeah, I think we did. Didn't we? Yeah, we did. Into chapter 6. Remember when x squared shows up with an equal sign? Get a 0. Factor. Each one equals 0. That's gonna keep happening throughout the course. So let me write that up. Whenever x squared shows up with an equal sign at any time, first off you get a 0 on one side, factor the other side, and step 3, each part equals 0 and solve. That's always the game plan. Let me copy it over here. X plus 6. So we have x plus 6. X squared minus 3. Right? Remember, didn't I write that up a couple weeks ago? We were dealing with a bunch of those. Yeah, you want to put that in your long-term memory because this will just keep happening and happening throughout the entire course. You'll be in the middle of doing some problem, fractions or whatever, and all of a sudden, x squared will rear its ugly head. There it is. It's like you're out on the ocean just sailing along and the sea monster rears its ugly head. We might have too much of an imagination, but there it is. X squared is there. So when you see it, you got to go right into action. Get a 0. That's got to be just like a knee-jerk reaction for you. When you see x squared, get a 0. Get a 0. Get a 0 where? On the opposite side from x squared. You want the other side to become 0. So x squared is over here on the right side. So that means I'm going to make the left side. So how do I do that? Just jump them over. Jump this over. Jump this over. That'll leave nothing over there and produce my 0. So x squared minus 36 minus x minus 6. So far, so good. When things jump over the equal sign, they switch their signs in front of them. Right? And then, is that good to there? Then we can combine that stuff. X squared minus 36 minus 6? Minus 42, right? We good to there? And now it's time to factor again. Right? Step 1 is get a 0. Step 2 is factor. This problem keeps going and going, doesn't it? So we need to factor that thing now. Now, how are you doing with factoring? That was the test we just took. I hope you're comfortable. Let me write multiply, add. What number's in the middle?
1.
-1, yeah. So I know some of you like the diamond thing. Would that help if I write the diamond thing?
Not right now.
Not right now. Multiply, right? You're trying to find two numbers that multiply to be minus 42 and add to be minus 1. Is that helpful? You can write that. That's helpful for you. Right? That's what we're basically... I'm basically going to try to get two parentheses now that do that, huh? I want two numbers. I want something here and something here that multiply to be 42, negative 42, and add to be -1, right? You always multiply to be the back number, add to be the middle, huh? So what times what's 42?
6 and 7.
Lots of things. 6 and 7, 3 and 14 or something, and 2 and 21. And how do you know what we want to do? Yeah, 6 and 7, huh?
And then give us -1.
Yeah, 6, 7. Now, how do the signs go?
Minus to the
Bottom
bigger
bigger.
number.
Yeah, bottom bigger, BB. Bottom goes on the bigger, always, right? Bottom goes on the bigger, BB. Bottom goes on the bigger. -7 plus 6. That makes sense? Bottom bigger. Whatever sign is on the bottom always goes to the bigger. Bottom bigger. So 6 minus 7 is -1, and they multiply to be -42. Those are my numbers. So that's how it factors, that means, right? That means the two parentheses, x is in the front, plus 6 minus 7. Right, those two numbers.
And then we solve for 0.
And so that's step 2. So step 1, get a 0. Step 2, factor. And then step 3, each part gets its own 0 and solve. So this part gets its own separate 0, or the second part gets its own separate 0.
X.
It's almost going to stop.
Minus 6.
Is that good? You see that? So each part got its own 0. Why? I don't want that to be some thing. Remember if we gave a reason a couple weeks ago? Why would that happen? Why is that okay to go from 1 0 to 2 zeros? Why is that
One
true?
side's 0, then the other side one of them has to be 0.
Why?
Because they're equals.
They're equals and they're being multiplied, huh? Yeah, remember? Yeah, if I say I'm timesing two things, it's coming out 0, what does that mean? Either one could be 0, right? If you times two things, multiply them, it comes out 0. Either one could be 0. See how they're multiplying, right? Parentheses, they're multiplying to equal 0. So the first one could be 0, because 0 times anything would be 0. Or the second one could be 0, because anything times 0 would be 0, right? That means either one could be 0. So then we just finish up. Just jump the 6 over. Going to be -6. Jump the -7 over. Going to be +7. There's our two answers. If you want, you could just jump from here down. It's going to be opposite signs. It's going to do that every time, huh? So all of that work, there's our two answers. They want you to put them in with a comma, -6 and +7. -6 and +7. Hold on. Yeah. And one of them's bad. Okay, honestly, I'm not going to do this on the test. But one of them, there's an, I mean, if that's not enough, there's one more trick.
Let's see it.
You can never make the denominator 0. That's never a real answer. What am I talking about? One of those is a bad answer, because if you go back to the original problem, he'll make one of the denominators 0.
It's a 6.
A -6 is a bad boy. Cross him out.
0.
If you put that -6 back in the original, it'll make that, for x,
What's 0 at
it
the
makes
bottom?
that bottom 0, which is undefined, which can't be. So the only answer is 7 after all that. So I'm not going to give you a trick one like that on the test. We have to cross one out, but there's a couple in the
If we
homework.
get something like that, what is no solution?
No. One of them, if they were both bad, then it would be no solution. But only one was bad, so we keep this one. He's the only answer.
Oh, okay.
It's only no solution if they're both bad. That won't happen. We good? Was that one fun?
Pretty fun.
It won't come to the casual, will it? This kind of stuff will take hours of your life. All right. All right. So take that one. So go ahead and get out try. So we got 3 things. We're going to do common denominator. What is the common denominator? X plus 3 and x minus 3, right? You need one of each. You need one of each, x plus 3, x minus 3. And what are you going to do with it? Top, top, top. All 3, right across the top. So in other words, x plus 3, x minus 3. And then the middle also. And then the right side. Is that making sense? I'm doing the same thing to the left side as I'm doing to the right side. Left side and right side. Right across the top. Top, top, top. So is that working out? So this guy cancels that guy. So you cancel straight up and down. Multiply what's left over. What's left over? 7x, x minus 3.
So at the end you get 7x.
And x minus 3 cancels x minus 3. And you got x minus 7, x plus 3. You getting all that mess? See how I cross-canceled and then brought down whatever was left over. Now we're going to take this 7x and multiply it in. What's 7x times x?
7x squared.
7x squared minus 21x, 7x times 3. Good. Now, what's going to happen? Everybody good with that left? What's going to happen in the middle now?
The minus.
Leave the minus 7. And what is x plus 3, x minus 3? Can I jump to that?
X squared 9.
X squared minus 9. Remember how the factoring? You could FOIL it all out, but that would be the simplified cleanup.
Oh,
Does
beautiful.
that make sense there? equals, right? You know what I mean? Is that too shortcut? If you foiled this all the way out, you'd get x squared minus 3x, and boom, boom, plus 3x minus 9, and then these guys would cancel, see, and it would just be x squared minus 9. On the right side, I don't know, we just got to foil it. X squared plus 3x, boom, boom, minus 7x minus 21.
Mr. Heron, the x plus 3 and x minus 3 does not multiply with each other? Right in the middle?
Right here?
Yeah.
That's what I just did, and I got x squared minus 9. Does that make sense?
Just around.
Everybody good to there? Everybody see what I'm doing?
Minus 21.
Right, so I just multiplied here, just distributed. Here in the middle, I just multiplied x plus 3 and x minus 3, got x squared minus 9. On the right side, I just foiled that up. Good?
Let's put that
Now this
4.
minus 7, there's still one parenthesis left, huh? Now minus 7 is going to go through those parentheses.
You need to keep your 1.
So here we go. So this will be 7x squared minus 20x. This guy's going boom, boom. Minus 7x squared plus 63. Over here, like terms, these two. Minus 4x minus 21. Are you tracking with me? So on that left side, 7x squared and minus 7, so they're gone. That's nice. So then we have minus 21x plus 63. Over here, x squared minus 4x minus 21. All right. What? Are we good to there? Questions I can answer to there?
Okay, and then x squared disappeared, then do we make it 0?
Exactly. Good. Everybody good with that? That's exactly right. We're out in the sea, sailing around. There it is. X squared has reared its ugly head. So when x squared shows up all of a sudden,
0
get a 0. Get a 0. Where? On the opposite side from x squared. X squared's on the right side. That means make the left side become a big A, 0. So that means you got to take these two and jump them, right? And they'll switch signs. They'll end up on the right side with opposite signs, 0 on the left. And then you know what to do. You know the 3 steps, right? Take it from there. Okay, so we're here. We see x squared rear its ugly head. We go, yeah, I know. Get a 0. So jump this guy over here. Jump this guy over here. So we get 0, x squared minus 4x minus 21 plus 21x minus 63, right? They show up in the other side, opposite signs. And now we've got a 0. So then combine like terms. Minus 4x and plus 21x is plus 17x. Minus 21 minus 6. Use your calculator. Minus 84. So that's step 1. Get a 0. Step 1, when x squared with an equal sign shows up. Step 1, get a 0. We did it. Step 2, factor. So now we're going to factor that. So remember how that works. You want two numbers that multiply to be the minus 84 and add to be the 17. So if I go, okay, multiply to be the minus 84, add to be the plus 17. So I don't expect you to, I don't know those off the top of my head. Just grab the 84 with your calculator. Just use your calculator. Grab the 84 and just start dividing by things. Just go divide by 2, divide by 3, divide by 4, divide by 5, divide by 6, divide by 7. And just every time you get an answer, see if somehow that can make the 17. Those two numbers can make the 17. You know what I mean? By that, do you know how to find this with your calculator? So you just take that number that you're trying to get to multiply, 84, and just try dividing it by things. Start with 2. 2, 3, 4, 5, 6, 7. So if you divide by 2, 84 divided by 2 would be 42. Ask yourself, can 2 and 42 somehow make the bottom 17? No way. No way. Divide by 3, what's that, 28? Can 3 and 28 make 7? No way. Divide by 4, 20. Can 4 and 21 make 17? Yeah. They can subtract to be 17, can't they? See what just happened? I just took the 84.
21.
And I just divided by 2, 3, 4. When I got to 4, they told me 84 divided by 4 is 21. And I go, oh yeah, 4 and 21 they subtract to be 17. That's my
So the
pair.
21 is plus.
So now let's put them in. That's our pair. So 4 and 20. Now how do the signs go? What's the thing I said?
Bottom to the bigger.
Bottom bigger. BB. Bottom bigger. So whatever sign is on the bottom, plus, goes to the bigger, plus. Right? And what's the other one? Minus 4 plus 21. 21 minus 4 is 17. And they multiply to be negative 84, don't they? That's my pair of numbers. Okay, we're almost there. So now 0 equals x minus 4, x plus. And if you want, you can just jump to the end now. It's just going to be opposite sign on both those, huh? Right? So the final answer, can I just jump to it? Positive 4, negative 21. We're done. And both those are good, by the way. Neither of those wreck a denominator. If you go back to the denominator, no problem, no problem. They're both good. They're both good answers. Does that make sense? I think we have time for one more good one. Maybe two if they're quick. Questions I can answer on that one. Getting the hang of that whole x squared thing? All right. So r equals v over j. So r equals v over j. And they're saying solve for j. They want to know, they want j alone. They can pick any letter they want. This is like physics formula or something. You know, this is what you do with science formulas. So you want to solve there for j. So how am I going to do it? Yeah, got to get j alone. So we have fractions. So remember, is this just two fractions? Yeah, it is. So I can just cross multiply, huh? I don't have to do a big old LCD thing. You tracking with me? In fact, all three of these, 11, 12, 13, they're all just one fraction on each side. You know, just make this c over 1. Just make that r over 1. Right? And then just go diagonal, diagonal. Remember that? Remember when there's just one fraction on each side? Those are easier. You can just go diagonal, diagonal, cross multiply. Whereas if there's three fractions, you got to do common denominator, top, 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 right? Everybody seeing that difference? So if you have three fractions or more, they're not going to give you more. So three fractions, that's when you got to do common number, right? Everybody with me? So you look back to the last problem. See how on this one we had 1, 2, 3 fractions in the beginning. So I had to do it the long way. Common denominator, top, 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 right? And cancel and bring it down, all that. But on this one, I just have two fractions. So this is just rj is 1 times v. And 1 times v is just v, huh? So rj equals v. So far, so good? Right? If you just have two fractions, just cross multiply. Now, what are we trying to get alone? J. So what do you got to do to get j alone? Divide by r, huh? Boom, there it is. J is v over r.
V over R is zero.
So that's the answer for number 11. Try number 12. Same kind of thing on 12, right? Just cross multiply. There's just one fraction inside. Just make that c over 1, right? Just go diagonal, diagonal. And they want me to solve for y. So they want you in the end to get y. They could pick any letter. They picked y. So you put this over 1, diagonal, diagonal. So ch squared
5548.
is 1 times 755y. That's just 755y. Okay, and how do we, what do they want? They want y. How do we get y alone? Divide by, battery, pin. Divide by the 755. Boom. There it is. Y's alone. It's that, huh? ch squared over 755. Those are easier. Yes, yeah, the order doesn't matter there. Yeah, you can totally swap that. And then number 13, d over pi r equals 7. So number 13, d over pi r is 7. We'll solve for r? Yeah, for r. They say 4r. So same thing on that one. Try that one. It's just one fraction on each side. Pi is just, it's, don't put in the number. You don't need to put in 3.14. Just leave it as pi. It's just a Greek symbol, right? It's actually the letter P in the Greek alphabet. Whatever. Just treat it like a letter. And the end, they'll let you type it in. They'll give you a little palette with pi as an option on the Math Excel thing. So it's just like any other letter. But you got to get it off the palette. It's not on your keyboard. You don't have a Greek keyboard, I'm assuming. So put 7 over 1, diagonal. So 1 times d is 7 pi r, or pi r 7. The order doesn't matter. So 1 times d is just d. Okay, and how do we get r? They want r. How do we get it alone? Divide by 7 pi. Divide by 7 pi. Boom, boom, there it is. D over 7 pi. Let's just do the first step on one more. I want to use every second here. One more. So that's number 13. We're good to this. What would be the first thing you would do on number 10? Yeah, you see this right here? That piece has got to be factored. Hey, any guesses how it might factor? They're so obvious how they write these.
They add to that.
R plus 5.
It's going to be r plus 5, r minus 1. Yeah, that's what it's going to be. We don't need to waste a lot of time making the diagonals and right? It's going to be r plus 5, r minus 1. You can double check it. It's right. It makes the plus 4, right? 5 minus 1 makes the 4 in the middle. Multiplies to be negative 5. That's the right factorization. Okay, so let's do that first. Let me recopy it for you. So number 10, 3r minus 3 over r plus 5r minus 1 plus 3 over r plus 5, 3 over r plus 5 equals 2 over r minus 1. Okay, so we good to there so far? And now, can I just cross multiply on this one? No, we have 3 fractions, right? We have to do it the long way. Common denominator, top. What is the common denominator? Yeah, one of each, huh? R plus 5, r minus 1. So you write it top, the whole thing. R plus 5, r minus 1. R plus 5, r minus 1. And r plus 5, r minus 1. That good? So let me just do the next step with you and we'll stop. I just want to get you out of the woods to the clear spot. That's the same thing we've been doing on all these ones, right? Common denominator, one of each type, top. Now, go ahead and cancel top and bottom, and bring down whatever's left over. Whatever's left over, bring down the leftovers. All right, so what is going to be... So this cancels this, huh? And the whole 3r minus 3 just drops down. Here, r plus 5 cancels r plus 5. Over here, r minus 1 cancels r minus 1. Do you see that? A lot of stuff canceled, and I just bring down what's left over. And you can take, notice there's no r squared anywhere. This is going to be a nice one. In other words, you don't have to do the whole get a 0. If you multiply this, here, I'll just finish it real quick with our last second. It's just r to the first. See how there's no r squared anywhere? That's why I'm saying this is an easier one. So you just combine like terms. 3r, 6r, minus 3 is minus 6. The other side's just 2r plus 5. Then you just go, oh, I got r on both sides. Get rid of one of them. right? I don't have to get a 0 or this. There's no sea monster here. I do something bad? Oh, 10. Thank you. I'm going too fast. Yes. I was testing you. Right. Well done. All right. So, and then this is 4r minus 6. This is 10. Add the 6. Add the 6. Boom. So 4r is 16. Divide by the 4. R is 4. So that was an easier one. All right. That was a lot of work. So this is the section due. Nothing else. Just this section. 7.5. You guys want to come on Monday? Are you coming on Monday?
Yes.
I'm just joking. There's no class Monday, so 7.5 is not due till Wednesday. I wouldn't put it off though. Until we hard when you wait. I would get it done right away.
Artist, quick to get.
If you have questions on the exam, I'd be